Space-time. Well, where do we start with space-time? What is space-time? We want to know what space-time is. If they're going to bend it and do all kinds of good things with it and explain gravity with space-time, we might as well know what space-time is, okay? And here, let's start very slowly, okay? We have here a set of number lines, which the mathematicians call dimensions or coordinates or something along those lines. No, they're number lines. And one of those is the number line known as time, which is not a dimension. It's not a structural dimension like length, width, and height. Okay, time is a number line, just number line. That's all it is. And time has no direction, but they always put a direction, as you can see there. They draw them as straight lines. Okay, and they put all these numbers in there. You know, all these number lines because they want to calculate stuff or show where they're at or things along those lines, right? And so they label these number lines, and here we build the matrix, okay? And this is what they're going to be bending. So I just want to go slowly so you see how we built this, because they always put this fishnet and you don't know where the fishnet came from. A lot of people don't know where it came from. And so I just want to show that, yeah, what you're staring at is really a bunch of numbers, and what is fake is the fishnet. You know, time is not a fishnet, neither is space. But they put a fishnet representing space-time, and what they're really talking about is a bunch of number lines, right? And then they get rid of the numbers, and what they do next is, guess what? They're going to bend this stuff. Okay, here it is. They bend it. Okay, and so that's the fishnet that you see in relativity. Okay, and so the question is this valid what they do? You know, because then they're going to put something on there like a star or whatever, and then you see the star rolling around space-time. And the question is this a valid thing? You know, here they build it little by little, right? They build this matrix. They get rid of the numbers. They just leave the canvas, you know, the fishnet, and then they bend it. They bend it and they say, look, we have all these number lines. That's what they are. And then they're going to roll a sun around it. Sounds neat? Sounds like a plan? Is this physics or what is this? So, you have to understand what space-time is. Space-time is just a bunch of number lines that concern the mathematicians. And you say, well, why do they represent it like that? Why do they turn in this physicality if it's just a mathematical abstraction? That's the question, okay? And here you see good old Brian Greene, just in case, because you might say, Bill, you invented this. No, I didn't invent this. Here you see Brian Greene, okay? He's going to roll the little ping pong ball around the bowling ball, right? And he tells you the moon is kept in orbit not because it's pulled by the Earth, right? But why? He says rather because of long curve in a space-time fabric that the Earth creates. So he puts the bowling ball there, you know, and he shows you how it's done. And the ball just keeps rolling around forever. Why? Because there's a depression in what? Space-time. All those lines that you see there, that's space-time. And what he's bending there are coordinates. Not really coordinates. What he's bending really is number line. Number lines are not coordinates. Coordinates give you location. And here they're talking about number lines, just pure number lines. And so, yeah, so this is what space-time is, okay? And so the question is, does that make any sense? Can you say that gravity is the bending of space-time if space-time is number lines and they're bending number lines? What sense does that all make? And so then you have all these people out there, and they say, oh, Bill, you're taking an analogy too literally. And there they made this cartoon. Understanding gravity of space-time is like a rubber sheet. Massive objects distort the sheet, and wait, they distort it because they're pulled down by what? And the teacher says, oh my God, says space-time is like this set of equations for which any analogy must be an approximation. And the student says, boring, I don't know. No, that was the wrong word. You should have said irrational. That's what he should have said. What these people are saying is irrational. And so what's the issue here? The issue is that these people, mathematicians, right, they say you're not supposed to take the analogy literally. You're not supposed to take the explanation, the mechanism that they're proposing literally. They're saying that they have these equations, these measurements out there, right? And they cannot present it in a language that the peasants out there, like all you peasants out there, you would not understand our math. So we have to somehow translate it, I don't know, the Klingon language to Spanish or whatever. It's very difficult. And so they say you can't really translate mathematics into ordinary speech. And so you can't take the analogy or the explanation or the mechanism too literally. That's their answer to this. And so the question is, why did they even try? If they cannot offer a mechanism, a rational mechanism, what is this nonsense of turning number lines, which they call coordinates or dimensions, turning them, because I'll even accept coordinates and dimensions, but they're bending coordinates and dimensions. What does that mean? So they're bending these number lines, and they're saying gravity is the bending of number lines. But don't take the analogy too literally. Don't take what I just said too literally. Don't take the explanation, the mechanism too literally. Then what am I supposed to conclude? And so they say, well, we're still investigating. We still don't know. But then, they talk everywhere as if they knew. They've already proven everything. And so we have all these contradictions out there where they've proven everything, they know everything, but then you say, well, that doesn't sound rational. Yeah, because we cannot convert our number lines into ordinary speech, and so this is the best way that we can do it for you peasants out there. But in our world, we talk math, we talk number line, we understand each other. But we can't talk to you because you know no math. And so I just want to know why this spoon falls to the floor. That's all I want to know. And they say, well, it's the bending of number lines. And when you call their bluff, and they say, well, you're not supposed to take the analogy too literally. What does that all mean? What is this? So are we ever going to get an explanation? And here you'll have some answers from some of the great minds of mathematical physics. And these are some of the contradictions that they have out there, okay? All the irrational explanations that we ended up with. You have self-creation of space and time. It's called Big Bang. Invisible massive black hole warps space-time. Invisible massive dark matter particles. Those are the ones that create the galaxy rotation problem or solve it. Invisible medium dark energy. Invisible tunnels to other universes, wormholes. Earth drags time around, proved by gravity probe B. Gravity warps time. You have a concept warping another concept. They have all these irrational explanations. And you say, well, does this make any sense? I mean, they don't have a single explanation for any phenomenon out there. And you say, how can this possibly be after so many, first of all, thousands of years of these people doing research, 400 years at least since the days of the scientific revolution, 100 years since quantum and relativity, a few or less for string theory, and still we have no explanation for any phenomenon. They don't know what magnetism is, they don't know what electricity is, they don't know what gravity is, they don't know what light is. And so where do we stand? And they say they've proven everything, they know everything. You can't publish a paper that contradicts relativity, string theory, or quantum mechanics. And I'm not talking about math, I'm talking about mechanisms, and they won't allow you to publish a mechanism. You have to put math for them to understand it, I guess. So the ones who don't understand are them. Normal people understand simple things. You say, how does a spoon fall to the floor? And I can explain it very easily. I'm going to do it with a pen. I hope you forgive me. Okay, here you have a pen. Okay, and I've attached something to it. It's called a rubber band, right? And I want to show you how I can make it fall to the ground because it's attached to my finger. So I let go of the pen and it falls down. Always falls down, never falls up. And if I want it to fall up, no problem. I can also do it this way in reverse. I can do gravity in reverse. Bling, see? So it goes up. Yeah. So I can do it either way because I have a physical mediator that everybody can understand. Okay, so I don't need any math. I just showed you a mechanism of how a pen can fall to the ground if every atom of the pen is attached to every atom on Earth. Do you believe it? Well, we don't care. We don't care if you believe. We just want you to understand it. Understand the mechanism we're proposing. And what these people are saying, we have no mechanism. Our mechanism is warped number lines. What do you mean warped number line? What is that? Are they strings? Are they canvas? Are they a fishnet? What are you talking about? And they say, well, you're not supposed to take the analogy too literally. That's the answer. And we don't do that anyways. That's philosophy. That's on the other side of campus, how the universe came to be, all that stuff, where the singularity appeared for the first time, called the Big Bang. Where it came from, did it come from God? Well, that's philosophy. We don't care about that. So these are the answers you get. And so, here you have good old Stephen Hawking. He's going to tell us a little bit about space-time. He says it's often helpful to think of the four coordinates. Calls them coordinates. And this is a mathematician, right? And he calls them coordinates. Of an event as specifying its position in a four-dimensional space called space-time. What does he say next? He says, it is impossible to imagine a four-dimensional space. What is he talking about? I mean, of course it's impossible to imagine a four-dimensional space because you're talking about number lines. And he doesn't even realize that. So he's saying he's got four number lines. He's trying to imagine what they look like. Of course he's not going to be. He cannot even imagine three number lines or two number lines. Because number lines have no direction or perpendicularity. Number lines have, you can put numbers in any direction you want. You can put the 4 before the 5 if you want, or after it. It doesn't matter. Numbers have no direction. But good old Stevie, since he was brainwashed so much with mathematics, he never picked up on that. Something very simple. Baby could have figured it out. Here you have another fellow. His name is Leonard Leo Susskind. You and I evolved in a world of 3 dimensions. We can't visualize more dimensions. I can visualize 3 dimensions in my head, but I use X, Y, and Z to describe them mathematically. Okay, so he's going to describe them mathematically. He cannot picture them. Now I go to 4 dimensions or 5 dimensions, I can't visualize them anymore. Yeah, of course, because you're talking about, not dimension, you're talking about number lines. That's one issue. But even if it's dimensions, I mean, how's he going to put a perpendicular dimension to length, width, and height? Of course he cannot picture it because no such monster exists in our universe. And I can't visualize them anymore. I can't say now, close your eyes and view in your head 5 dimensions because I can't do it either. So we're stuck needing what? Mathematics, because evolution didn't equip us to be able to visualize quantum mechanics. It didn't equip us to visualize 11-dimensional space-times. Evolution did this to us. These are the answers. This guy teaches at Stanford, and this is the ridiculous thing that he says. And just in case, we have their, their guru came first before any of them. This is good old Heisenberg. What does Heisey say? He says, the most important step was not to see that our language is not sufficient to describe the situation. Okay? And in such a world as the path of the electron, they are quite understandable in the ordinary realm of physics when you have to do with stones or with gas and so. But they are not really understandable when we have to do with electrons. At the same time, we know that these words, which are used for describing the experiment, that they have only limited range applicability. That these words, for instance, when applied to electrons, really don't mean much. In other words, all these people, they cannot put into words their math. Because, math has nothing to do with physics, which is what people want to know. People want to have a rational explanation of why the spoon falls to the floor. Or why the pencil falls to the floor. And I give them a rational explanation. It's tied and it falls. See, there it is. Look, I'm holding it down here, okay, and there it goes. Bing. Goes down. Goes up also. I can show you how the pen falls because I'm showing you a physical mechanism. But of course, if I remove this, why would it fall? If there's nothing here, absolutely nothing, then why would it fall downwards? And push, you can't do it with particles. We've already covered that. You have to do it through pull, and gravity is a pull force. And the only thing you had to do all these 10,000 years is identify the mediators, the physical mediators that we cannot see or touch. And hopefully, so that means we can't go to the lab or to the field and try to prove gravity or detect the mediator of gravity because it's invisible and intangible. So only an idiot would go out there and try to prove or detect what is invisible and intangible. No, this is something where you put your feet on the desk, drink a beer, and visualize how Mother Nature could be doing gravity. And hopefully you reach the same conclusion as I did, that everything has to be attached to everything else for there to be attraction. Otherwise, you cannot produce pull if you don't have some kind of elongated object between two atoms. Okay, and so that's where we stand today. Anyways, what do we have today? Well, we have all irrational explanations. Here it is one more time. Okay, they have all these irrational explanations coming out of quantum mechanics and relativity, and they get away with murder because they say this is all philosophy. We don't care about all this. We just do equations. And when we give you all this nonsense, it's because you poor peasants. You don't know enough math to understand an explanation given in math, which is only a description because they cannot explain anything with equations. You can only describe with math. And so they cannot give you an explanation. When they do give you an explanation, it's irrational, and they dismiss it as saying, well, don't take it literally. You're asking for something that belongs to the other side of campus, belongs to philosophers of physics, of science, of who knows what.